Now we are moving to another measure of dispersion, that is quartile. Then we will move to percentile. So quartile is a very important measure of deviation, dispersion. So let us study it with help of an example. Okay. So here in example, the data given is 106, 109, 114, 116, 121, 122, 125, 129. So you are asked to calculate the first quartile, second quartile, and third quartile. So we are using a method not exactly given in this example. So this is all gives you only an approximate value. So what we are doing is to use this formula, that is k into n plus 1 divided by 4. K corresponds to first, second, or third quartile, which quartile that you want. So for example, if you want to calculate in the first quartile, so then 1 into 8 plus 1 by 4, so that will be 2.25. Okay. 2.25 means, since this is an ordered data, you look at the second position and the third position. So it lies between somewhere here. So Q1 will be equal to the second position 109 plus 0.25 into this difference, that is 5. So it is 110.25. So this is how you calculate the quartile. So in this method, they are calculating the quartile, but this is an approximate. But the exact way is to calculate by this one. For example, in the case of a second quartile, it will be 2 into 8 plus 1 by 4. It is 4.5. So you can take the fourth number, and so since it is 4.5, you can take the average 116 plus 121. The answer is 118.5. So this is how you find the quartile of a data. So this is also a measure of dispersion. Now come to the interquartile range. So what do you mean by interquartile range? So interquartile range is calculated by this formula, that is the third quartile minus the first quartile. This will give you the interquartile range. So why we are calculating it? So this interquartile range is an important figure to draw the box and whisker plot that you will see later. So you can see a box and whisker plot. What we are doing is we will find the quartile, that is Q1, then we will find Q3, so Q2 will be the middle. Then we can plot the data, and the minimum value will be somewhere here and the maximum value will be somewhere here, and if you observe some data to be here and here, okay, here, that is an outlier. That means you get an idea about the data. In some cases you can omit these outliers and then collect the other data. So this is all about the quartiles.